Hi, good afternoon, everyone. This is the last class for the fifth chapter, that is flow through the open channels. In the yesterday class, we have discussed regarding what are the conditions for the most economical sections of rectangular and trapezoidal channel sections, and also we have seen simple problems on most economical sections. In this class, also we are going to discuss regarding the problems on most economical sections of rectangular and trapezoidal channel sections. Let's go for the problem number 1. These problems are very important. That's why I'm repeating here. Again, I'm going to explain here two more problems. So, a trapezoidal channel of 3 meters base, side is 3 meters base, side slopes 1 in 1 is laid at a slope of 1 in 1000. Estimate the discharge in liters per day when the depth of water in channel is 0.5 meters. Take the value of C in Chassis formula as 36. So he has given that values are B is equal 3 meters and slope I is equal 1 in 1000, and he has asked that calculate the discharge in liters per day, and also he has given D is equal depth of water in channel is equal 0.5 meters, C is equal 36. So first we have to write the given data. Side slope is equal, side slope he has given 1:1, and bed slope I is equal 1 in 1000, base width is equal 3 meters, depth of water D is equal 0.5 meters, and chassis constant C is equal 36. So he has asked that discharge in liters per day. Let's go for the solution. So first we have to, he has asked that discharge. So we know that discharge is equal, Q is equal area into velocity. So first please see here. Here I am going to write the total solution here in chart. After that we will discuss one by one. So Q is equal, he has asked Q is equal, we know that area into velocity. So here velocity is equal, we know that formula according to Chassis formula, C into root mi. Again here m is the hydraulic mean depth, m is equal, it is a ratio of A by P. So that's why we have to calculate first of all area of a trapezoidal channel, then after we have to calculate the perimeter of a channel. So from that we can get m value, hydraulic mean depth, it is a ratio of A by P. If you calculate the A and P, then we can get m value. So remaining values are he has given in the problem. So when we substitute the above values, then we can get V value here. So here we can get V value. After that we have to substitute in Q value. Q is equal to A into V. Here we can substitute the V value, then we can get the discharge. This is the total solution. So here we are going to step by step procedure. So here first of all you have to calculate the area of a channel, the trapezoidal channel. That formula is B plus N into D is equal, here you can get 1.75 meter square. So next, length of the slope, one side of the slope is equal, we know that D is equal under root 1 plus n square. Here you can get that value is D into under root 1 plus n square. Here you can get that value of length of the slope side is equal 0.707 meters. So next we can go for the perimeter, weighted perimeter. So already we have calculated A, and here we can go for the perimeter. So perimeter P is equal B plus 2D into under root 1 plus n square. Here we have to substitute the above values, then we can get P value is equal 4.414 meters. Here you can calculate the m value. M is the ratio of A by B. Here you can get that m value. M is equal 0.397 meters. After that we have to calculate here V value. So V is equal, we know that C into under root mi. From that formula we can get V value is equal 0.717 meters. So next we will go for the discharge. We know that discharge is equal A into V. Already we know that A and V value. So here we can get the Q value is equal 1.255 meter cube per second. So this is the discharge of a given problem. So here we have to convert it into the liters per day. So he has asked in liters per day, that's why it should be converted into the liters per day. Ultimately we can get, after simplifying that values, we can get the discharge is equal 108,432 liters per day. 108,432 liters per day. This is the discharge in liters per day for a given problem. Let's go for the second problem. So this problem on rectangular channel. A rectangular channel of width 4 meters is having bed slope of 1 in 1500. Find the maximum discharge through the channel. Take the value of C is equal 50. Same, he has asked the discharge. We know that discharge Q is equal area into velocity. So velocity is equal to, we know, C into root mi. Again m is equal to A by P. So that's why here we have to calculate first of all area of a cross section and perimeter of a cross section. So for the most rectangular section, we know that the conditions, it should satisfy the two conditions. So that is breadth of a rectangular channel should be twice of the depth of a channel section, and m is equal d by 2. From that conditions we should calculate the area and perimeters here. So first of all you have to write here given data. Width of the channel B is equal 4 meters and bed slope I is equal 1 in 1500. C is equal 50. For most economical rectangular section, it should satisfy that B is equal 2D. So from that you can get D value. D is equal 2 meters. He has given B is equal 4 meters. From the relation between the condition we can get the D value is 2 meters. And the second condition is m is equal to d by 2. From that we can get m value is 1. So from that we know that for the area of a rectangular channel, area is equal b into d. From that we can get 8 meters square. So next go for discharge. Q is equal AC into mi. So here V is equal C into root mi. So here V value is substituted. From that we can get Q is equal to A into C into root mi. So you have to substitute the above values in this formula. Then you can get the discharge 10.328 meter cube per second. This is the discharge of a given rectangular channel section. So thank you everyone.